Likewise, those are the problems related to this soil degradation. Now we are going to talk about how to stop this soil degradation.
Recording in progress.
Yeah, how to stop this soil degradation. And here we talk about the first very common problem, which is soil erosion, right? Soil erosion is really higher in steep slopes and hilly areas. Maybe the soil is not well established, loosened soil. It also very liable to, this is very sensitive to experiencing high soil erosion, right? So this soil erosion we can control, right? We have to control the soil erosion actually because it loses the topsoil and it will lose the nutrients and it decline the nutrient levels there, so that eventually it leads to soil degradation, right? So we have to use the different sustainable farming techniques and better land management practices, so that we can mitigate, prevent, and even reverse the land degradation. Okay. I hope you all can hear me.
Yes, madam.
Okay, good. All right. At the farm level, we can do different mm, farming strategies. We can practice different farming strategies. For example, if it is a very steep hilly area, we can practice the terrace farming, right? Terrace farming we can practice, so that we can cultivate some rice there in the terrace kind of paddy fields in the hilly areas. In Kandy, Matale, we can see those kind of terraced lands, okay? And also, for example, think about the tea cultivation in upcountry area. Most of the tea cultivated hilly areas, steep slopes, right? So what are the actions they have taken to reduce soil erosion? Please give me your answers into the chat box. Good. Making stone walls, yes. And salt, very good. What do you mean by salt? Cultivation using contour lines, very good. Planting cover crops. Yes, everything, those kind of things practice. Tell me what is salt? The one who write it, actually, it's a very good technique. Very good. Answer is quite good. What is SALT? SALT means sloping agricultural land technology, right? Sloping agricultural land technology. They are different practices combined and applied, right? And also here there we cultivate the crops in the contour lines, right? Crops in the contour lines and then tree lines. Then cultivate tree lines after that. Tree bands. Trees in like in bands along the contour lines, right? So that's how they develop salt, and also another kind of stone walls we can establish, and cover crops and everything. So kind of a collective practices doing in the sloping agricultural and technology. Okay, here you can see the terrace farms, how it is look like. You know, then the water is stagnating in each and every terrace, and it will reduce the soil erosion and transporting soil into the downstream. Then we can plant when wind breaks, right? We can protect soil by planting windbreaks. What do you mean by windbreak? What is this windbreak? Please put your answers here. Okay, what is windbreak? Don't you know? Okay, actually this some yes, more answers, please. That is good. Okay. All right. So windbreak is um, planting trees, right? Planting trees along against to the wind direction, right? Planting trees, tall trees, and not only tall trees, but we can mix up the heights of the trees. Okay, mix up the height of the trees uh, to achieve the triangular shape, right? Triangular shape to control the wind wind velocity. Okay. So yes. You all mentioned different answers. Control the wind pressure, We can plant tall trees to avoid wind. Yes. Reduce speed of wind, avoid wind damages. So windbreak is a barrier. Yes, yes. Okay, cultivating area. Okay, sorry. Windbreaks. Oh. All right. So here the idea is this is the wind direction. We plant trees against to this wind direction, and these are the farming areas. These are the farming areas, right? Farming areas, and very little amount of wind coming in. Okay, so that is the simple explanation for these windbreaks. Okay. And then let's see what are the socio-economic environmental benefits, right? It's conserve the soil, it conserve the soil, reduce soil erosion, right? It definitely reduce the soil erosion because soil particles bind with the root zone so that they are not easily detached. Improve the microclimatic conditions for the crops and non-timber for non-timber products produce. They produce non-timber forest products. What are the non-timber forest products? What you can say? Right. What are the non-timber forest products? Other than timber value, what are the things we can get from the trees? Other than the timber value, that is why we call that as non-timber. What are the other benefits from the trees? We can obtain tangible benefits other than timber. But that they should be tangible products, okay? Not services, but the product other than the timber. Why? For example, right? For example, fuel wood. Fuel wood is a non-timber forest product. It's not a timber, but it's a fuel wood. Okay. Then fruits, nuts, and also leaves. Okay. Those ones. So why you are why you are giving me names of the plants? No, I'm asking what are the non-timber forest products? Okay, non-timber forest products coming from the trees. Here we talk about planting trees against to the wind direction, right? So from these trees we can get non-timber products, right? Non-timber products. So if we go through what are the examples for these non-timber forest products, they are fuel wood and then leaves for foods and maybe fruits and nuts or all the resins, right? Gums, all these are non-timber forest products, right? And it improved the microclimatic conditions for the crops as well. How it is happening? Here you can see, this is the crops, right? This is the crops and dominant wind come here from this direction now. And this wind going through these layers of, there are several lines of trees planted, right? Normally we maintain the triangular shape by increasing, by establishing taller trees in the middle, and then shorter ones. Okay. This is the plan. Okay, so likewise, we maintain the triangular shape, right? Like this. So that what happened to the wind, very less wind go through this tree barrier. That is what we call filtration, right? Filtration. Some wind change their direction like this. That is what we call deflection. Deflection, filtration. Those are some of the things happen to the wind. So that very importantly, what happened, the crops feel very good conditions because they can't feel the very high wind velocity particularly, so that evapotranspiration getting lower. It will help for increasing the water use efficiency in the crops, and also it increase the microclimatic conditions there by increasing RH, relative humidity, and temperature getting down, in this area, so that for the crops and animals, if maybe this area may be allocated to crops or animals, whatever it is, they feel good weather conditions because of this living barrier. Okay. Okay, so that is what happened. Now, I hope you can see the full screen now. Here we cultivate, right? Uh, here we cultivate tree lines. Like this. Tree lines against the wind direction like this. Here, these areas used for the animal husbandry or livestock production or whatever it is. So that is the windbreak. So these are the common benefits of windbreaks, right? It reduces the soil erosion, increase crop yield, protect livestock, provide wildlife habitats, enhance aesthetic values. Those are some of the other benefits. Some of the other benefits in this windbreaks. And it so that what happened? The wind filtered and going through these farmlands are very low. The amount of wind and the speed of the winds again reduced because it blocked the tree windbreak. Tree lines always act as the physical block. Okay, so that it reduced the wind speed. Increase the livestock production because they don't feel much temperature during the dry season, and it will increase the relative humidity and the temperature getting reduced. So the livestock feel like the good conditions for them, and it will reduce the stress levels of them and produce more heat, more meat, uh, and promote their growth and development, so that it will helpful for livestock production as well, and reduce heating and cooling cost. That also good benefit. Then the other method is prepare stone walls to prevent soil erosion, right? Here what happened, what we are doing is along the contour lines, we make some stone buds in the field, make some stone buds in the field against to the slope. I mean the, yeah. Along the contour lines, we establish. So we can use rocks or stones along the natural contour line. And also we can do another practice reforestation that also help to protect soils. You know, most of the hilly areas, upcountry areas after the tea plantation, long time after, I mean, in the most of the tea plantations, now they are degraded, right? They're becoming, converting into the marginal areas. Okay, so after they identify this one area, it is a marginal area, we have to practice reforestation practices or restoration practices to get back this soil status again back to the normal conditions, right? So that reforestation and restoration also helpful to protect soil. And conservation tillage or reduced tillage. Conservation tillage in the sense we don't use much tillage, right? Deep tillage practices we are not following. We are not practicing. Okay, so only very few amount of tillage we will do, so that it is also helpful to conserve the soil quality and the soil structure, those kind of things. Otherwise, it will lead for more soil erosion and also, soil erosion and also the soil structure, right? If we do deep tillage, it definitely damage the soil structure. That also not good. So we not recommending heavy machineries in agricultural plants or agricultural fields, because once they used more and more, the soil compaction happens, soil aeration get introduced, right? Soil infiltration definitely get introduced or decline. So those are the serious problems, okay, of deep tillage. Then the other practice is surface covers on soil surface, such as trees, pastures, and meadows. Okay. Yes. What we do? We cultivate surface covers on the soil surface, so that we can use cover crops for this purpose, right? Cover crops. In rubber plantation, what is the most commonly used cover crops? Please put your answer into the chat box. What are the different cover crops we use in maybe different cultivations? Right. For the rubber plantations, it's pure area. Good. And yeah, okay, good. That is correct. So in other agricultural lands also we can practice the same. Okay. So we can use surface runners for this purpose. Surface runners, and what is the use? What happened after we establish cover crops in the bare ground, right? It will reduce the soil erosion, because the cover crops always cover the topsoil, right? So that think about the rainfall. Raindrops not hit the bare ground, but they hit only the surface of the cover crops. And also, yeah. And also they have some kind of root system. That root system also binds soil particles together and reduce the decline the soil erosion. Okay. Right. And also we can plant trees as well, right? Trees having a good root system, and it binds particles, soil particles, so that we can reduce the soil erosion thereby the other new. So these are some of the another method we would do here, the cover croppings, right? And then the other method is intercropping, right? So already, if it is a already degraded land, intercropping also very if it is agricultural area, we can actually practice the intercropping, right? Intercropping so that different plants are growing at the same time. The other very good method is crop rotation. Crop rotation, right? So different crops growing in the same area, and time to time we change. Time to time we change what crops are cultivating in that area, right? So the other method is organic farming, so that it will increase the soil rehabilitation. Farming methods that reduce soil loss. These are some of the farming methods that reduce the soil loss. Strip cropping, terracing, no-till planting. Those are some of the practices. Terracing, contour cropping, cover crops, and windbreaks. They all are soil conservation measures. That soil conservation measures that reduce the soil erosion. Now we are going to talk about our second land degradation problem, that is soil acidity, right? Soil acidity. Sorry. That acidic soil, we have to control soil acidity as well. Right. So when we control the soil acidity, we need to do it in early as possible, right? We need to do it as early as possible, because when acidity spread into the subsoil, it will be a serious problem. So we can't maybe apply some of the correction measures to control the acidity in the subsoil. Okay, so subsoil acidity is controlling the subsoil acidity is very difficult and very costly. So that once we identify the soil acidity in the topsoil layer, we have to apply the control measures, right? So how do we measure the soil acidity? What is the test? Soil test to measure the soil acidity. Yes, testing the soil pH is the method. Yes. Good. Now let's talk about what are the farming practices recommended for this minimizing soil acidification, right? One thing is matching nitrogen fertilizer. Matching nitrogen fertilizer to the crop demand, right? Because there's a crop requirement is different, right? Crop requirement is different, so that normally in agriculture department they know these things, this information they know. What type of nitrogen NPK require for the particular crop during the planting time, maybe during the mature stage, and then the all growth stage. So we have to apply that nitrogen fertilizer only for the demand of the crop, right? Not excess, right? Then efficient irrigation management is also helpful to minimize the leaching, and then we can plant deep root perennial species, so that their tap roots and the other big root system, they can taken up the nitrogen from the deep layers, and they use those nitrogen for the growth and development. And we can actually apply lime. Regular application of lime will neutralize the soil or increase the soil pH, right? So it is a good method for application of lime. And the other method is we can actually grow acid tolerant crops, so that it will helpful to restore the land while maintaining the kind of agricultural area. So for example, sugarcane and banana, they are the examples of acid tolerant crops. Yeah. Then the fertilizer use, right? Fertilizer use, if we talk about this nitrogen fertilizer usage, right? Nitrogen fertilizer usage, think about like this. It contains ammonia, right? And NO2 or whatever it is. What happened? This nitrogen, after apply the fertilizer, this nitrogen in the fertilizers dissolved in soil water. NO2 minus and NO3 minus, right? Nitrite ions, and they convert it into nitrite ions and nitrates, right? So these excess nitrate ions, what happened? Let's see, this is the groundwater table, right? They're going downwards. That is what we call the leaching, right? This nitrate maybe I mean, if there are no very big trees around, that nitrate ions go in even in the deep layers. Okay, into the deep layers, and this is groundwater table DW. And these nitrogens go into the groundwater as well. So leaching of nitrate increased during the rainy season because more water available, more vertical movement of water happened within the soil profile. So that more, if we apply more excess fertilizer, definitely a big portion of nitrate ions they are going into the groundwater system. Okay, so that also very concerning thing. Then that's all about the fertilizer use and how to control it. Them. The mainly we can do application of nitrogen fertilizer according to the requirement, right? According to the requirement, and also we can do it application of fertilizer in a split application, right? Not all together, all at once, but time to time we apply little amount so that the so that the soil acidification may be reduced. Okay, right. I will take. I want 5 minute break. Right, it's 5 o'clock. And come back. I will come back after 5 minutes. Please tell me whether you can see it and hear it. Okay.
The Franklin district is home to some of the most productive and durable soils for vegetable growing, but it's prone to erosion and subsequent soil and nutrient losses. In the late 1990s, local growers set up guidelines for erosion control as part of the Franklin Sustainability Project. In 2014, AgriLink New Zealand, alongside growers and erosion specialists, produced the Erosion and Sediment Control Guidelines for vegetable production.
We have a project called Don't Muddy the Waters, and that project is all about quantifying how much erosion is happening on properties and then how much can you capture in sediment control devices. Our focus in this project is looking at the vegetable industry. Cultivated land obviously has erosion issues, and so then how do you minimise erosion on a cultivated vegetable property? What's nice about this project is it builds on a massive amount of work that's been done previously. So back in the early 90s, there was a really large storm event that occurred in Pukekohe, and that really galvanised everybody to get involved in a project that looked at a whole range of sustainability issues. One of those key issues was erosion and sediment control, amongst irrigation management, plant health, but erosion was what that project lived and died on. That project was the Franklin Sustainability Project, and it was a fantastic example of getting a whole group of growers together, the council, and coming up with a whole range of sustainability measures. The nice thing about that was you have everybody coming together rather than splitting off and doing whatever they thought was the best solution. People need to have the numbers and the details, and that's what this most recent project is all about. How do you quantify what's happening in the measures that the growers have put up? Ultimately, you need to have sediment control. Our issue with sediment control is there's two key elements. First of all, there's bed load, which is the really heavy stuff that drops out quite quickly. The second element is suspended sediment, and it's the suspended sediment that gets into the waterways that causes a whole lot of issues downstream. This project has had a number of trials that have run. One of them was in Levin, where we looked at the size of the riparian strip, and in Pukekohe, our focus has been on sediment control. So what is the effectiveness of a silt trap? And how big a silt trap do you need to be effective? We have a 4-step process when you look at a paddock. So the first step is, what is my paddock? How large is the paddock? What's the slope? That's my paddock assessment. Step 2 is, how do I minimise the water that enters that paddock? So that way you only deal with the water that directly falls on the paddock. Step 3, how do I deal with the water that does fall on the paddock? So that's erosion control. What do I do in the paddock? Do I have cover crops? Do I do wheel track ripping? What am I doing in the paddock to stop that soil from moving? And the 4th step is sediment control. So what do I need to do to stop the water that leaves the paddock having lots of sediment in it? i.e., do I need a silt trap? Do I need an earth bund? That's my final step.
This is the stuff that you want to look at here. The whole paddock assessment.
What we've done over the years now is bunding on the headlines, silt traps, and wheel track ripping. and that minimises, not totally eliminates it, but soil erosion. In the wintertime, we put cover crops in, and that holds the soil in place at times. The tracks are panned over the summertime or when you work the ground, and the water can't drain freely. So with the wheel track rippy, it opens up a little V, lets the water drain in and soaks away, in theory. It's working on slopes up to 15 degrees. On heavy downpour, you can actually encourage that soil movement, so you've got to pick and choose which paddocks you do it. By loosening up the soil on a 2 to 3 inch rain, downpours, it will move. So it has its advantages and has its disadvantages also.
What we have here is a forebay, and the forebay is before it goes into the main silt trap. The idea of a forebay is it's much, much easier to clean out. You can get into a forebay much easier than you can get into a silt trap. What happens in the forebay is the bed load drops out super fast. So as soon as you slow that water down in the forebay, the bed load drops out, and you can see here the build-up that's just occurred in the last month. Water then flows into the main silt trap, and that's where we deal with the suspended sediment. So in our trial, we are monitoring how much water is flowing into the silt trap, and we're also monitoring how much is flowing out. We have, as part of this project, a NIWA sampler, and the NIWA sampler grabs water every 6,000 litres. Takes that sample, we aggregate that sample up, and later on in the lab we measure how much suspended sediment is in each of those samples. With a vegetable operation, obviously you want to try and minimise how much gets into your silt trap. So you want to keep as much soil as possible, of course, on your paddock, but at some time in the year, irrespective of your erosion control, you need to have sediment control. And this is all about sediment control. So this is all about minimising how much leaves your property and goes into the greater environment. The outcome is ultimately a whole lot of information that says this is how effective your measures are, and that can then be delivered to councils and to NGOs that ask how effective they are. For the growers themselves, we have an app that shows how effective these different control measures are. And the nice thing with that app is they can dial up what their mitigation measure is, be that a silt trap, be that cover crops, and it shows how much sediment has been captured in those traps, or how much the other mitigation measure has affected them.
Okay, now you have listened to that video, right? He's talking about how to control the soil erosion, right? Tell me, what are the different practices mentioned about within that video? If you understood, what are the different practices he mentioned to control this soil erosion in that video? Please give me your answers into the chat box. But no answers? Didn't you hear it? What are the things you could see in that very big cultivated area, but there are some basins kind of structures. What are they? Yes, wind barriers are there. Good. And anything else? What are the big structures in between that farming area? Very in the middle of the farming area? Yeah, apply cover crops also. Correct. They talk about cover crops as well. Anything else? What are those big things, the kind of ponds? They are sediment traps, right? They are sediment traps, okay? So what they wanted, actually, they mentioned about to conserve the land, we want to know this data. We want to know data, how much is going to, how much is, what is the soil erosion, the level of soil erosion, right? So that need to be done, that need to be no. So that they wanted to understand how much of sediments transport from this system to downstream. So that's why those structures building in the land area, and they get the data, how much of sediment transport from one place to another place, right? So that they wanted to do the corrective measures, right? What are the corrective measures? Only apply water. The second step, they mentioned only apply water, irrigation water to the root zone, not to the other areas, right? Exactly to the root zone of the crop, so that they have more moisture there, and the tree, crop can absorb moisture very efficiently. Okay, so that is the other thing. And then also they can calculate before sediments and after do the corrective irrigation technique, what is the sediment. Okay, so that they can, yeah, you can't see any presentation because I'm talking about the video that we see. Okay, that we see. So so those are the things that the scientists express. He wanted to mention those kind of things. And yeah, okay, so it's a quite good initiative. Okay, so we will go again into the rest of the presentation. Okay, then the third problem, land degradation problem, is soil salinization, right? Soil salinization. How to prevent this soil salinization? To do that, we want to optimize the irrigation, right? Optimize the irrigation. Why this soil salinization happen? What is the reason? Why this soil salinization happen? Okay, your answers. Welcome your answers. That we discuss in the soil degradation. Okay, so put your answers into the chat box. Why this soil salinization occur? Why this soil salinization happen? No. Over irrigation without drainage, that is happened because of it leads to soil erosion, right? Irrigation with saline water. It's the main cause. Okay. So what do you mean by soil salinization then? මොකද soil salinization කියන්නේ? Increase the soil salinity. ඇයි එහෙම වෙන්නේ? Yes. Accumulate was accumulating the salts, accumulating the salt in the soil. Accumulate salt in the soil. I may salt accumulate when probably mainly if we irrigate with saline water, maybe if we irrigate with wastewater and brackish water, they all contain some of the salts. Okay, so that when increase the evaporation, yes, correct. When increase the evaporation, what happened? That salt accumulate on the topsoil as a layer. We can see kind of a white crust on the topsoil, right? In very drier areas, kind of Kalpiti and Puttalam area. Puttalam area, this is a common problem, very common problem. So what happened because of this soil salinity? It changed the osmotic. Normally water absorption by the plants hindered because of this soil salinity. It changed the water potential in the soil solution, and so those kind of things happening. So the soil salinity is really bad thing. So we want to control that. Okay. So how to prevent this soil salinization? One way is optimize irrigation, right? Here we want to reduce the salty water usage, implement maybe drip irrigation, and rainwater harvesting system use. Those things we can do. But don't all the time we have to concern about not to irrigate with brackish water, saline water, or whatever the salty irrigation water. And we can add organic matter and manure to keep soil moisture and also reduce irrigation. More irrigation, we can reduce it. And don't use, it's good to not to use deep tillage or heavy machinery. So that if we do that, this salt can be transported into the deeper layers in the soil. And we can use actually the cover crops or mulch to protect the ground surface so that evaporation may be reduced. Then we can do increase the drainage for better flushing. Flush off the topsoil and remove salt from the ground surface, right? And then we can plant salt tolerant crops. So it can tolerate some of the salinity conditions without reducing the productivity. Then we can mechanically or manually, we can remove some of the salt crystals from the topsoil. And reduce evaporation in the topsoil, grow cover crops. You can use cover crops and manure. So this soil conservation measures we can apply by individual farmers, right? We can apply individually as farmer level, right? And also we can all the time that video also stress about that we can apply the conservation measures individually, but it is not much productive. It is not much effective because if I apply soil conservation measures, but the next farmer not apply those things, so what happened? It is useless, right? So we have to collectively apply all the conservation measures, soil conservation measures, so that the results are very much promising, right? So in that case, we have to have national level actions, right? We have to have national level actions, need to promote research and development. That you could see that in that video, it's a kind of a project they implemented there, and they wanted to calculate the sediment transport, the soil erosion rate in that particular area before applying this soil conservation measures and the after applying soil conservation measures, right? So they are monitoring it. Understood? So we need that kind of research and development activities. And also what are the site specific nutrient requirements so that we can do some of the applications. The farmer can apply actual amount of fertilizer according to the crop demand, right? There are some information we have. So yeah, that those are the research and development we can look into. And produce fertilizer recommendations for the crops, different crops. Promote farmers on sustainable farming systems and increase the extension services. That means extension officers can be going to the village and meet the people at the CBO level, community-based organizations, and aware them because of aware them about these different issues. And aware the farmers, yes. And giving some kind of incentives for sustainable land management practice. Yeah. So with that, we could finish the soil conservation. I'll share another video.
Imagine a group of people lived on the land. They grew food and raised animals, and their children could go to school. However, due to a mismatch between land use and its sustainable potential, the land started to degrade. Their farm could no longer grow food as it did before. Everyone became hungry and poor, and eventually they had to move to other lands or to cities. The same story can be heard around the world. Some 25% of the world's land is degraded, it is impacting the well-being of 3.2 billion people globally.
You hear this?
That is 2
Not.
out of every 5 people. Land restoration is one of the 3 key
Can you hear?
strategies that can
Can
help
you
solve
hear
the
this
problem and
one?
improve.
Please let me know.
Yes, madam.
Okay. Then fine.
Imagine a group of people lived on the land. They grew food and raised animals, and their children could go to school. However, every 5 people. Between land use and its sustainable potential, the land started to degrade. Their farm could no longer grow food as it did before. Everyone became hungry and poor, and eventually they had to move to other lands or to cities. The same story can be heard around the world. Some 25% of the world's land is degraded. It is impacting the well-being of 3.2 billion people globally. That is 2 out of every 5 people. Land restoration is one of the 3 key strategies that can help solve the problem and improve life on land. It can also have significant co-benefits for all the United Nations Sustainable Development Goals, or SDGs. For example, it can increase water infiltration into the soil, which can then increase land productivity and create more income and food. This can reduce poverty, hunger, and improve health and opportunities for education. More and better quality of water can also be accessed. With all these, people who are forced to migrate may be able to come back to the productive land. The extent of restoration co-benefits and the potential risks and trade-offs vary widely among the SDGs and their respective targets. The co-benefits of the process of restoration and restored lands are also different for each SDG. To maximize opportunities across multiple SDGs, the International Resource Panel proposes 4 strategies. First, complete holistic and systematic analyses to identify potential synergies and trade-offs. Second, apply a landscape approach to planning and implementation. Third, develop targeted solutions adapted to different parts of the landscape and taking into account unique social, environmental, and economic contexts. And fourth, invest in areas where persistence is likely. When it comes to land restoration investments, we are so used to the conventional approach where we often address different objectives, such as agricultural production and biodiversity conservation, independently. Instead, we need an integrated landscape approach. It considers variable land potential and is designed by and responsive to all the stakeholders involved. And to maximize total return, we should target research and investments to those parts of the landscape that are most likely to respond and where recovery is likely to persist. In this way, we can ensure that we identify and realize the multiple potential benefits a land restoration project can bring about for the Sustainable Development Goals. Learn more about land restoration through the IRP's publication, Land Restoration for Achieving the Sustainable Development Goals at www.resourcepanel.org/reports.
Okay. Okay, with that, we can finish this part as well. Before going to starting the next chapter, we will look into the module, go through the module, probably would be a good idea. Yeah, and you can see, right? Okay. Go through the. Yeah, we started with environmental degradation and we discussed about, right, what is environmental degradation and the causes for them, for that, and land degradation, major categories of land degradation, and how to prevent it, soil erosion, and now we have discussed about that. And desertification, land neutrality, LDN targets, here also mention it. And yeah, with that, we finished the land degradation. Okay. So now we are going to go to the air pollution. Okay. So we will start with the air pollution. Right. I hope you can see the screen. Is that? No. No. You can't see, right? Now, we will start with this air pollution. Air pollution means alteration of physical, chemical, and biological properties of the air. And this air pollution, because of this, we can say any solid, liquid, or gaseous substances present at the atmosphere in such a concentration that may be tend to injurious to the human beings, right? So that is the air pollution that we see, right? Any solid, liquid, or gaseous particle substances present in the atmosphere when in such a concentration that may tend to be negatively impact the human beings and other living organisms. These are the composition of atmospheric gases. Time to time, we emphasize that the nitrogen 78%, oxygen 20%, carbon dioxide 0.03% likewise. And let's see what are the causes for air pollution. Natural processes are there and human activities are there. Natural processes are forest fires, dust storms, and volcanic eruptions, right? So tell me, what are the human activities that leading for air pollution? What are the human activities? What are the human activities cause air pollution? Fossil fuel burning, yes. What else? Deforestation, GHG emissions, okay. Industrialization, okay. Yeah, you can see, right? Fossil fuel burning, vehicle emissions, industrialization, extensive agricultural practices, all these are some of the causes for air pollution, right? When we concern about the air pollutants, there are several types of categories of air pollutants, okay? One is primary pollutants, secondary pollutants, natural pollutants, and artificial pollutants. Okay, those are the categories of air pollutants. Let's see what are the primary pollutants. Primary pollutants emitted directly from the identifiable pollution sources. That is emitted directly from the identifiable sources, right? So primary pollutants include carbon compounds and, for example, carbon dioxide and carbon monoxide, sulfur compounds, sulfur dioxide, different sulfides containing carbon, sulfate, right? Those are the things, sulfur compounds and hydrocarbons, right? So all these are primary pollutants, hydrocarbons, benzene and methane, particulate matter. For example, dust particles and also heavy metal particles, heavy metals like zinc, cadmium, lead. Those are some dust particles contaminated with heavy metals, and toxic substances such as asbestos, beryllium, copper, and chromium, those kind of things. Everything are primary pollutants because they emitted directly from the identifiable sources. The secondary pollutants are ozone, photochemical products, and photochemical smoke. That means after emitting primary pollutants, they react together and generate or produce another type of pollutant, right? Primary pollutants react together and produce another type of pollutants. In the atmosphere, they are secondary pollutants. For example, ozone and photochemical products. Okay. So the different things get together and combine, react together and produce. Then natural pollutants are there. For example, dust particles, volcanic eruptions, smoke, and other particulate matter, they all are natural. And artificial pollutants are concentrated in industrial and urbanized areas. That means human activities generate these pollutants. They are totally artificial. Right. When we talk about pollution sources, these pollution sources are two types. Okay. The first type is stationary or single or point source. Right. That means stationary means not mobile, not moving. Right. And it is a point source, not moving. That means it is in one point. Right. So we call that as point sources as well. Point source. So for example, what are the point sources? They are industrial process chimneys and power plants, oil refineries likewise. They are located in one place. We call that as point source. And mobile source. Mobile sources means highway vehicles, trains and automobiles. Those are mobile sources. Right. These are the major three negative impacts of air pollution, right? Negative impacts of air pollution. Hereafter, what are the three negative impacts? Greenhouse effect, acid rains, and photochemical smoke formation. Those are major three negative impacts for air pollution. Other than that, we can say another air pollution, that is ozone layer depletion as well, right? So now I'm going to give you the activity in this class. So I will divide you into different groups, right? Four groups, and you have to get together and discuss about these things, about these four negative impacts of air pollution. One is greenhouse effect, acid rains, photochemical smoke formation, and finally ozone layer depletion, right? So I will give you 30 minutes for that, right? You have to prepare a small note or kind of a presenting thing with you, and I will ask you to come and talk, right? So probably you want to appoint a group leader for this, right? Group leader for this, and group leader can assign someone to talk, or either group leader can talk about the issues, okay, about this different impacts. Okay, so understood this? Everyone, can you understand what is this continuous assessment here? It's activity. Yes or no? So your activity is, I will try type the activity here. So you will have to do this. Uh, Okay. Can you see the assignment now here? So you want to discuss the following impacts in your group and need to be present to the class. Group A, greenhouse effect. Group B, acid rain. Group C, photochemical smoke formation. And Group D, ozone layer depletion. Now I'm going to divide you into the 4 breakout rooms, right? 4 breakout rooms, and you want to discuss there within the rooms about these different effects. And time to time, I will ask you, ask each group to present, right? Okay, understood? You want to talk with me or chat with me? So other classes, so there are some student activities, right? You have to do it. Understood or not? I want your response. ඔගලන්ට තේරුණාද මම කියපු මේ activity එක? Pramod, are you there? Pramod, are you there?
Yes, madam.
Okay. So this is a student activity, right? ඔක ළමින්ට කියන්න මම definitely ගන්නවා. මේ විදිහට තමයි lectures කරන්නේ. Otherwise you are nothing doing here, right? So you have to do it and present it today. In the same time, I will give you like 30 minutes, maybe 30 minutes would be enough for this. Within the group, you want to discuss and prepare kind of a guideline, and you want to go through it. Okay, that's the way of doing this. I will divide you into the group breakout rooms, and within the rooms you can discuss. Anyone, everyone, you can talk within the group, and then present those. Okay, so that's the way of doing here. Okay, so ඔගොල්ලෝ කරලා තියෙනවද මේ જાති activity එකක් කලින්?
No, madam.
Okay, very good. Then it's fine. It's okay. Saturday and Sunday students are there, that's fine. So I have the numbers with me. The numbers, all the things I can get from the Zoom platform. So I know who are attending and everything I know. So in the room 1, group 1, there are students like can you see the rooms? No. I will.
Recording stopped. Recording in progress. 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 Recording stopped. Recording in progress.
number 1, they talk about greenhouse effect. Greenhouse effect. Right. So, who is going to talk about the greenhouse effect from room number 1?
Good morning, madam.
Good.
I am present our topic.
Yeah. Thank you.
Okay, madam. Can I start now?
Yes, yes.
Good morning, dear madam and all of you. Our topic is ozone layer depletion. Ozone layer is Earth's natural sunscreen that contain a high concentration of ozone molecules. Ozone layer depletion refers to the thinning of the ozone layer in the Earth's stratosphere, mainly due to human-made chemicals. Causes effect of ozone depletion causes chlorofluorocarbon, halogens, carbon tetrachloride, and methyl chloroform. These substances release chlorine and bromine, which break down ozone molecules. Causes of ozone depletion: health risk, increased UV rays can cause skin cancer, characters and weakness to immune system, and eye damage. Second, harm to the plants and animals. UV rays harm crops and marine life. Third one, climate impact. Ozone depletion affects the atmospheric temperatures and can influence global weather patterns. Solution: ban and control ozone depleting substances.
Sorry. We can't hear you. We can't hear you. Are you talking or not? Is that all? Finish?
No, madam. We have already discussed such things
Uh,
and avoid unnecessary aerosols and all cooling appearances
uh,
and using eco-friendly vehicles.
mhm.
Uh, reducing the air pollution and using green technology. Also, the following the international agreements. I mean, the Montreal Protocol,
Yeah.
like that.
Okay. Is that all?
Yes, madam.
Okay. Good. Room number 1, we prepared a presentation. So, yeah, I will allow you to share so that everyone can share what you have. Okay, that's fine. Okay, so this is room number 104. You, now,
4, madam. 4.
4. Okay, good. So you have done the ozone
Ozone layer
layer
depletion.
depletion, right?
Depletion.
Mahasul, you are raising your hand. Why? Any problems with you? Any concerns? No. Okay. So please down your hand. Uh, and thank you very much. You have done something. And yeah. Okay. But you have presented it voluntary. That's really appreciating and very well done. Yeah, okay, we will now move into our second group, second room, maybe. Okay, so the room number 1 or the group number 1, we will move into them, right? Okay, you can share your presentation. Room number 1. Anyone from room number 1 who is going to present? You can share now. Okay, now you can start.
Good morning, dear madam and dear students. Today we will discuss about greenhouse effect. Uh,
Yes.
what is greenhouse effect? The greenhouse effect is a natural process that warms the Earth's surface. How it is work? First, sunlight reaches Earth and Earth emits heat. Then greenhouse gases trap that heat and natural greenhouse effect are continuing. Enhance the greenhouse effect. Then we will discuss common greenhouse gases, carbon dioxide, methane, nitrous oxide, water vapor, ozone, sulfur dioxide, carbon monoxide, such things. And then we move on to major human activities that increase the greenhouse gases. Burning fossil fuels, deforestation, industrial activities, agriculture things, waste decomposition. Impact of greenhouse effect, global warming, melting glaciers and rising sea levels, extreme weather conditions, destruction of ecosystems and biodiversity, agricultural and food challenges, ocean acidification. How can we reduce greenhouse effect? We can use clean and renewable energy. Sorry, we can use solar power, wind power, such things, and we can reduce transportation emissions, and we can plant trees and protect forest.
Yes. Is that all, or you are going to continue me?
Yes, madam.
You are continuing or finish? Delivered?
Finish, madam.
Oh, okay. Nice. Excellent. Right? Very, very nice presentation. And yeah, you have done, you have actually go through key points. So that is really appreciating and do the things within the time. That's really good. I really appreciate your work, the group work. Okay. Right. Now we are going to go to the next group, the group number 3. Group number 3. No, two. Sorry, room number 2. I forget it. Room number 2, talking about the acid rains, right? Acid rains. Yeah, hurry up, please. Room number 2. Number 2. No one? I have the list. Then I will read for you. Okay, I will read out who are the students in this group number 2. I will give still time to come up and present your present about the topic. Yeah. Here EPM 266. 266. Here. EPM 266 and then the 278, 228, 260, 263, 281. Who is going to present? Before now.
Sorry,
Yeah. Yes.
sorry for the late, madam.
Why did you late? Why did you late?
No, miss, no, miss. I am present for the reason for. Shall I present for the
Yes, you
what
can
is
present. Yes, you
acid
can
rain?
present, but you take so much time here. Why is that?
Yes.
Okay, go ahead.
Okay. Acid rain, it forms when pollutants like sulfur dioxide and nitrogen dioxide, that means nitrogen oxide, are released into the air mostly from burning fossil fuels. These gases mix with water vapor in the atmosphere to form sulfuric acid and nitric acid, which falls to the earth with rain. In simply we said, polluted rainwater that contain acid from the air.
Is that finished? Or is that all? During whole 30 or 45 minutes, you did all only this amount?
Now means we discuss about each one.
Okay, then you can present it. You can present it.
All things?
Yes.
Okay, miss. Okay, ma'am. Sorry.
Others also can help you. Right.
Sources that mean reason for. I told the reason. Another one. Volcanic eruptions. That mean SO2.
බොරු කරන්න ලෑස්ති වෙන්න එපා. හරිද? ඉතින් වැඩක් කරන්න කිව්වම ඇක්ටිවිටි එකක් දුන්නාම නිකන් ඉඳලා ඒකත් ප්‍රසන්ට් කරන්න නැතුව ඉන්න හදේ. ඒවා හරියන්නේ නැහැ. අනික් ළමින්ටත් එක්ක කියන්නේ ඒ ගෲප් එකේ.
Effect for the acid rain, soil degradation, plant damage, water bodies, that mean acidified lakes and rivers harming aquatic life, damage for the building, that mean erodes stone and metal, damaging historic monument and infrastructure. It affect for the also affect for the human health. That means indirectly affect by contaminating drinking water and food chains.
Okay. Please raise your hands. Raise hands who are in this group. In this group. All the ones. Please raise your hands. In this third group, no? You are in third group. Isn't it? The second group. I can't remember. Second group. Is that all? Only Only four students are there. I have the list. Only 5 students. Who is Geetma? Geetma is there? Geetima Sarat Chandra. She is there here? Okay. Right. So, මොනවද ඔයගොල්ලන් කරපු දේවල්? Please still raise your hands. I will ask one by one. Okay. So, EPM 2186. EPM 186. What you have done?
Yes, madam. Yes, we discuss all about the acid rains.
Yeah, acid rains. Any, what is your contribution for this? What you have done?
Sorry, madam.
Yes. මාව නිකන් බොරුවට තරහ ගස්සවන්න එපා. බොරු වැඩ කරනවා නම් ඒ විදිහට කරන්න ඕනේ. හරිද? Then the other one. Who is Udit? Udit, what is your contribution for this one? For this group activity? Udit.
Sorry, madam.
What is your contribution for this group activity?
Madam, we all discussed how to reduce this acid rain effect in the plant and some humans too.
එතකොට ඇයිද මම කතා කරනකොට පැය ගාණක් හිටියේ මේක ප්‍රසන්ට් කරන්න? ඔයගොල්ලෝ ඩිසයිඩ් කරේ නැද්ද කවුද මේකට එන්නේ කියලා? එහෙම කරන්න බෑ. හරිද? මාත් එක්ක මම කෝඩිනේටර් ඇකඩමික් කෝඩිනේටර් මේකේ ඔය විදිහට වැඩ කරන්න බෑ කාටවත්. මේ බැච් එකේ. හරිද? ඇක්ටිවිටීස් කරනකොට ඒකට රෙස්පොන්සිබිලිටි කන්ට්‍රිබියුට් කරන්න ඕනේ. ඒවා හරියට කරන්න ඕනේ. එහෙම නැතුව ඩිග්‍රී ගන්න බෑ. හරිද? ඒක හොඳට මතක තියාගන්න. And Sandali. Then. Sandali? Sandali?
Yes.
Who is Sandali?
Madam.
Yes. What did you do?
Yes, madam.
Yes. What did you do
Madam,
during this time? Oh. මොකද ඔයා කළේ? මේ ඇක්ටිවිටි එකට ඔයා මොකද කරේ? මම අනිත් අයගෙන් අහනවා ඔයා මොකද කරේ කියලා. කියන්න පුළුවන් වේද? Before that you tell me what did you do? Oh, Sandali? Time waste කරන්න බෑ. Right now 7:10. If you not talk, I will wind up this session as well. Huh? Sandali? And then Kasun not talk with me. Kasun, are you there?
Yes, madam.
Yes. What did you do for this?
Madam, I discussed.
Hi.
Madam, I discussed with group members effect of acid rain.
එතකොට මේ අය ඔයගොල්ලෝ ඇක්ටිව්ලි මේකට කන්ට්‍රිබියුට් කරනවා වගේ මට පේනුන්නේ නැත්තේ. ඔයගොල්ලෝ මම කතා කරනකොට ආවේ නැහැ ප්‍රසන්ට් කරන්න. කවුරුවත්. එහෙම වෙන්න බෑ ඉස්සරහට. හරිද?
Excuse me, madam. I'm sorry.
My connection problem is lost. I have, madam, presentation. When I present it,
Yes, you can present.
okay, madam. Mm. Acid, acid rain. Acid rain is a high level of nitric and sulfuric acid caused by ascension of sulfur dioxide and nitrogen oxide. This gas react with water vapor in the atmosphere. Environmental effects, effect for the soil, acidified soil, harming plant roots and reduce nutrients, water bodies, lowers pH of lake and rivers, killing aquatic life, forest damages leaves, stunt growth, weakness trees, effect of building and structures, damage limestone, marble, and concert, reduce lifespan of infrastructures, effect of the human health does not directly harm humans, cause fine particles in the air that can lead respiratory issues, economic impact, damage to agriculture, forest, and fishes. How to prevent and control this acid rain? Use clearly. Use cleaner energy source, wind and solar. Install scrubbers and factors. Promote public transport. Implement environmental regulations. That's all, madam.
Okay. Now, what is the problem of this group? Tell me. What is the problem of this group? As you understand, as a group, what is the problem?
We are discuss, madam, all things, and we chat. We write chat group all things. Group එකෙන් leave වුණාට පස්සේ අර group එකෙන් අයින් වුණාට පස්සේ ඒ කිසිම දෙයක් අපිට ගන්න බැරි වුණා. ඒ කියන්නේ මැඩම් අර අපි group කරලා තිබ්බනේ. එතකොට අපි ඒ chat group එකට අපි discuss කරපු සේරම දැම්මා. හොඳද? හැමෝටම බලා ගන්න. එතකොට මේ ඒවා කිසිම දෙයක් මේ කියන්නේ ආය අපි ඒකෙන් leave වුණාට පස්සේ බලා ගන්න විදියක් නැති. ඒක මම දන්නේ නැහැ කොහොමද බලන්න පුළුවන්ද කියලා නා.
එතකොට දැන් මෙතන ප්‍රශ්නයක් තියෙන්නේ ඇත්තටම ඒක දෙයක් එහෙම මේ ටෙක්නික්ස් මතම ඩිපෙන්ඩ් වෙන්න බෑනේ. ඔයාලගේ hand out එකක හරි මොකක් හරි note එකක් දාගන්න ඕනේ, right? The first thing I can understand now what you have encountered, what are the problems. The first thing, you don't have a group leader, I guess. Do you have a group leader?
No, madam.
That's the reason, right? When you assign to a group task, the first thing you have to appoint a leader, right? All others, you want to listen, you want to be careful because of that, the group leader can lead the things, right? Then you want to understand at the end of the time, one student anyway, you want to present it and find out who is the present, right? Talk about that the group discussion, the team discussion is not there, I guess. Maybe you want to talk about what are the things you want to the technical things or the academic things, you just discuss, but not the way of doing this. හරිද? එතකොට එහෙම කරන්නේ නැත්නම් මේ වගේ group activity එකක් success වෙන්නේ නැහැ. Understood? So that is the problem of your group. Okay? So don't do that. Don't rely on only the things in this Zoom environment, because it is not sometimes you can't get back. After you leave in the group, you can't get back. That is obvious. Okay. So you when you having this kind of group activity, you can do it by conversations can go on. I mean the verbal conversation you can do it. ඔයගලන්ට කතා කරන්න පුළුවන් ඒ Zoom environment එක ඇතුලේ. But ඔය chat කරන ඒවා, ලියන ඒවා, ඒවා ඒක ඇතුලේ දාගන්න එපා. හරිද? ඒවා තියාගන්න ඔයගලන්ගේ maybe WhatsApp or whatever another kind of communication way. Okay, so that is those are the things you want to improve and you want to concern in future activities. Okay, good, right, thank you. Then we will move into the third group.
Okay, good morning, all of you. Our topic is photochemical smoke formation.
Can you please go to the slideshow mode? Slideshow mode, yes, good. Better.
Right, okay. Photochemical smoke formation. Photochemical smoke is a type of air pollution formed when sunlight reacts with nitrogen oxides and volatile organic compounds in the atmosphere. This reaction produces harmful secondary pollutants, including ozone, peroxyl nitrates, and other oxidants. Human health effects. Exposure to photochemical smoke can lead to several health problems, especially in vulnerable populations such as children, elderly, and those with respiratory conditions. Respiratory issues, eye and throat irritation, reduced lung function, cardiovascular problems, increased mortality. Environmental impacts. Photochemical smoke harms ecosystems and biodiversity. Damage to vegetation, ozone damage, plant cells, reduce photosynthesis and crop yield. Forest declines, prolonged exposure weakness trees, making them more susceptible to disease and pest. Acid rain formation. None contributes to acid rain, which harms aquatic life and soil quality. Reduced visibility, smoke creates a brownish cell. Economic consequences. The formation of photochemical smoke leads to financial burden, healthcare costs, agricultural losses, tourism losses, regulatory costs. That is enough, madam.
Okay, very good and excellent, right? So this is kind of a, maybe you might not heard about this photochemical smoke before, even before. So it's a kind of a new for you, and you have done a good, you have find out the good content, right? So that is really nice. I appreciate that work. Yeah, maybe you might have kind of a more communication within your group and somehow manage to come up with the presentation and present, right? So can you share your experience in this group activity for others as well?
Yes, madam. We discuss together on this topic, and they involved all of the members, our team.
Yeah, I mean, what do you think your successful steps or success criteria? What do you think you have done these things to come up as this outcome?
Yeah, our team have 10 members. I think they involve this as a team. They share all of their details, and our present maker is Indunil.
Okay.
He make the presentation and share.
Hmm. Okay. All right. And at what time you'll decide who is going to talk? I mean, at the beginning or middle of the work or end of the work?
No, madam, beginning
Beginning.
in this activity.
Yeah. So who is the group leader? Do you have a leader?
Leader is Mr. Indunil.
Okay.
He made the presentation and we share the details.
Okay, nice. Excellent. Right? So you know what is the group work and how to do it, and teamwork, you know how to do it, right? As a group. Excellent.
Thank you, madam. Thank you very much.
And I will love to hear from the greenhouse gas team. That may be room number 1 as well. They also done a marvelous job. Anyway, can come up the presenting person in this room number 1, greenhouse effect.
Yes, madam.
Yes. Please, please talk with me. While that, can you close the presentation? The one who shared it. Presentation close, Karan, please. අතන තියෙන close කරන දැන් presentation එක close කරන්න. Okay, I will.
Recording stopped.